So in this unit, what we're learning about is the periodic trends. And when we look at the periodic table, which was developed by Dmitri Mendeleev, we have the metals on the left side of the periodic table and the nonmetals on the right. So the trend in increasing metallic character is we start with the most non-metallic over here on the right side, and we become more metallic as we go to the left. We also become more metallic as we go down the periodic table. So the most metallic elements are at the bottom left, and the most non-metallic are at the top right. On the periodic table you see a staircase, which kind of is the dividing line between metals and nonmetals. But right along that staircase, all the elements along that staircase, with the exception of aluminum and polonium, are called metalloids. They're kind of like in between metals and nonmetals. So metals are lustrous, meaning they're shiny, they're ductile, they can be made into wire, they're malleable, you can roll them into thin sheets or whatever shape you'd like, and they're not very brittle. But the most important property of metals is that they conduct heat and electricity really well. Nonmetals are the exact opposite, where they're poor conductors of heat and electricity, they're good insulators. Metalloids are kind of in between, they're semiconductors. So, the first trend we're going to look at with respect to the periodic table is the size of the atoms. Because the size of the atom determines how strongly it holds onto their electrons, and how strongly it holds onto their electrons determines their chemical properties. So if you look at this, you can see that the smallest atoms are up to the top right, and the largest atoms are down near the bottom left of the periodic table. So the two trends that you observe. As you go from left to right across a row, the atoms become smaller. This is because the nucleus has one more proton each element you go over than the previous one, which means that it will pull the electrons in closer. So the stronger the nuclear charge, the more it will pull the electrons in. But another trend you observe is that it gets bigger as you go down. And the reason for this is each row on the periodic table indicates that a new shell has formed. Think of it like a Russian doll, where each row down on the periodic table indicates that a new shell is being added. So, the next trend we're learning about is ionization energy, which is the energy required to remove an electron. So, the smaller elements, which are at the top right of the periodic table, require a lot more energy to remove electrons from than the larger elements you'd find at the bottom left. And the reason for this is if you think of them like magnets, okay? When you hold magnets close together, like you would have with the oppositely charged ends of magnets close together, so like a positive and negative, like you would have with a proton and electron. If you have an atom that's small, they're relatively close together, and they feel each other's effect fairly strongly. If you have a larger atom where they're further apart, you don't have as strong of an attraction. So it requires far more energy to pull electrons away from a smaller atom than it does a larger atom. Okay. Now, the metals, which don't hold on to their electrons that well, when they become ions, they become cations, which are positive, and become smaller. Nonmetals gain electrons, and when they do that, they become bigger because they add more electrons to their shell, and that increases the amount of repulsion you have between the negative electrons. So you can observe the trends here. And you still, as you go down a row on the periodic table, again, you're adding energy levels. So comparing all the -1 ions, you'll see that the smallest would still be fluorine because it's further up and to the right. It still has less energy shells. The next trend I want to talk about is electronegativity, and this is the last one we'll talk about. And this refers to the strength an atom has when attracting electrons in a bond. This is very similar to ionization energy with one exception. The noble gases don't form bonds, so we don't consider them to have any electronegativity. They do have ionization energy, however, because it does take energy to pull electrons off, but they don't form bonds, so they don't have electronegativity. So again, the larger atoms, which are in the bottom left of the periodic table, their electrons are far away, and so would the electrons be of an atom bonding to it, so it's not a very strong attraction. The smaller atoms, like fluorine, which is the most attractive element on the periodic table, holds not only its electrons close, but the electrons of any atom it's bonding to very closely as well. So those are the trends. We're good.